So let's look at an example where a higher order model, which is given as GS equals having 1, 0 and 3 poles, and we are asked to find a transfer function having the structure of a first order plus time delay model. So this step 1, we have to express this in the form of what is called this gain and time constant formulation. If you remember that, in that case, they will have to have expressed in terms of say tau s, tau 1 s plus 1, tau 2 s plus 1, tau 3 s plus 1, and so on. So to do this, we rewrite the transfer function as so to make this to be 1, we have to multiply it by 10. So if we multiply it by 10, it will be 10s plus 1. So you have to multiply the numerator also by 10, and it will end up getting 10s plus 1. To convert the same, we have to multiply it by 5. So we'll have 5 and then 5s plus 1. And to get this to be 1, we have to multiply it by 2. So again, numerator multiplied by 2, and we end up getting 2s plus 1. So which can be written as 10, 5, 2, leading given 100 times negative s plus 1, 10s plus 1, 5s plus 1, 2s plus. Now we have to express this in terms of a first order plus time delay model. To do so, in a step 2, what you have to do, we'll have to express all the terms in terms of time delay except the dominant time constant. Now here, what is the dominant time constant? So this time constant is 10, this 5, and this is 2. So this dominant time constant, this tau 1, here is 10. Okay. So you have to retain this term, and for all other terms, you have to approximate by time delay. So for doing this, we know that we use this approximation e to the negative theta s equals 1 minus theta s, giving us the formulation that if you have something negative beta is plus 1, so that becomes, and if you have tau js plus 1, that becomes e to the tau js. Okay. So now let's look at this. We have g, if I write it as say gs will be again 100 s plus 1, 10s plus 1, 5s plus 1, 2s plus 1. If we approximate all the terms, we'll end up getting for this term, we'll get e to the power negative s. So if I write g approximated s, the gain term remains there. For this term, I will have e to the negative s. We retain the dominant time constant term. So we have 10s plus 1 that remains there. For this one, will be approximated e to the 5s. And this term will be approximated e to the 2s. So now you see that we have 100 over 10s plus 1, negative s. Here, if I take this term on the numerator, it becomes negative 5s, and this becomes negative 7s. So we'll have 100 over 10s plus 1, which eventually gives us G approximated S will be 100 e to the power negative 8s over 10s plus 1. So this is our approximated first order plus time delay model for this model here. So you see that if you are only using the Taylor series expansion to get an approximate model for this process, we end up getting this.